Wetlands, Connecting Diversity. I'm KCP's coordinator, Adrienne Shaw, and I'll be the host for this webinar. We also have Nicole Triggs, the KCP communications coordinator, ensuring that the webinar series runs smoothly in the background. As we're waiting for people to join us, we will launch a couple of polls. We're going to talk about where you're based, what is your affiliation, and we added a third poll just to get an idea of your familiarity with the current topic today. So here is the first poll. If you could take the time to just click. We still have other people joining, so the results are still coming in. We'll just wait for people to log on, and I'll share this poll once it's done. Okay, I'll share the results of the poll. So we have about 23% from East Kootenay, 46% from the West Kootenays, and we have 31% from elsewhere in BC. Now for the second poll, if you can talk about what your affiliation is, just click. We still have a few more people coming in. All right, I will share the results of this poll as well. So we have 19% from nonprofit, 31% are consultants, 31% are government, and we have 6% student and 19% other. Now I'll be launching an additional poll to see what your experience is with mapping tools. And if you could take the time to just answer that, just click on one answer. This will give David and Deepa an idea of how to sort of specialize their presentation if they know what mapping tools you're already familiar with. All right, I'm just going to end the poll and share the results. So looks like 73% are familiar with Google Earth using KML files, and we have 40% who have used interactive web maps like iMac and ArcGIS Online. 13% have experience with all of the above, 13% with none of the above, and 7% with other. And then we have 0% for full GIS like Esri ArcGIS, Grass, and other software programs. Excellent, thanks for sharing with those polls. Today is the third of 4 webinars. These are all excellent speakers, and I'm very excited that we've engaged them all in our webinar series. The next webinar series will be Lentic and Loadit Riparian Assessment, a Standardized Approach, and that'll be Monday, March 12th, 10 PST and 11 Mountain Standard Time. I'd like to say thank you to our sponsors, and without them, we wouldn't be able to do activities like this. And just to go through a run through of the webinar information, the webinar will be approximately 45 minutes with 15 minutes at the end for questions. As an audience member, you will be on mute, and we'll be on mute for the duration of the presentation so that there isn't distracting background noises or feedback. If you're not familiar with the Zoom platform, take a moment to locate your control panel by hovering your mouse over the bottom of the screen. You can adjust your video layout between active speaker view, the presenter, or gallery view, the presentation. Enter any questions you have in the Q&A box, and they will be answered at the end of the presentation. If you're having any technical issues, please put your questions, comments in the chat box, and the KCP Communications Coordinator, Nicole Trigg, will be monitoring the chat and will do her best to help you. The webinar will be recorded and made available on our website. So I'd like to first introduce David Poon. David has worked in soil and nutrient management with the BC Ministry of Agriculture since 2008. David earned his undergraduate and master's degree in soil science, but his passions lie with putting information to work for people. Often that means putting soil information to work so farmers can make the best use of fertilizers and manure. That has taken shape of interpreting soil information to manage for better crops, helping regulators understand the implications of their decisions for environment and farms, and making it easier for crop consultants to relate soil information to crop productivity, runoff, or leaching concerns. David Poon is also a professional agrologist. I'd also like to introduce Deepa Filatow. She is a self-professed earth science generalist and an expert on the provincial standards and holdings of superficial geology, ecosystems, and soil information for British Columbia. This includes 1,000 GIS projects with a total of 25 million inventory polygons, 26,000 soil pit descriptions, 3,000 scanned and georeferenced legacy maps, and associated standards, reports, and field data. Deepa has been the provincial bioterrain specialist for the Ministry of Environment since 2001. She is a professional geoscientist and is an articling agrologist with a BSc in physical geography from UBC Vancouver. Deepa spent many years mapping ecosystems, soils, and terrain in all regions of the province and has the privilege of working in interdisciplinary teams with top-notch ecologists, soil scientists, GIS specialists, wildlife biologists, to name a few. Outside of work, Deepa enjoys teaching, coaching, cross-country skiing, telemark skiing, gardening, singing, hiking, and dining. She is a dedicated wife and a mother of 2 kids. So welcome, David and Deepa. I'll pass the presentation off to David, and he will do the introduction, and Deepa will follow up.
Good morning. Okay, so I can see my screen. I'm thinking that you guys can see me and my screen as well. Holler if you can. All right, so like...
David, your screen, it hasn't come up yet.
Oh, no? Oh, I'm sorry. Okay. And we practiced this too. That's right. Okay, that rings a bell. Okay. Yeah, so I am going to talk a little bit about soils and how this project all started and set Deepa up to knock it out of the park, so to speak. So how this project started is how a lot of year-end projects start. You have this little extra money, your boss asks you a question, do you have any ideas on how to use it? And I had this thought in my mind for a while that, you know what, it's got to be easier for people to find soils data. Because at the time, we were still having people, not a lot of people, but people who know about this information come into our office and go through our cabinets, and they would look through map sheets, really large map sheets, like the one you see here, looking for soil information or derivatives of it, like agricultural capability. So you either have these large map sheets or these reports with fold-out map sheets, which are great. I still love them. Problem is, A, not everybody really knows that they even exist, and then 2, you've got to be able to get your hands on those maps. And then when you do, you know, it's reminiscent of when I was a kid going on road trips. We didn't have things like mobile phones, Google Earth to help us navigate. We'd have to pull out the old, you know, atlas and find the right page that we were on, figure out where we were in the world, then flip a few more pages to, you know, get some other information. And it was much like that with SOLA's information. That was how I felt about it, and it's why I felt like it's got to be easier. Now, that was a couple of years ago, but that's not to say that the underlying work for the tool that we're going to show you and talk about was an overnight success. There's been a lot of work that preceded the current project, and one of those products was a set of georeference scanned maps, which really started to, you know, one of the things that paved the way for SIFT. And again, you know, that was it was a great thing, but it had its limitations, right? And if you knew how to use georeference files, it could definitely help you figure out where you were. But, you know, you're still looking at a lot of Greek that you need to know how to interpret. So you see all these symbols, and you still need to go, you know, to another page perhaps in the report to figure out what that means. And if you want to get some information that's related, might be management information, you then have to go to another report to figure that out. So it wasn't just about, you know, making the map easier to get to, but the information that goes with the map easier to get to and use. So the idea was, conceptually, why can't we have that type of information in the same way that we interact with a lot of other information when we're using Google or any of those newer mapping products? So it doesn't look like this, but this was the concept. And, you know, what was the driver for this? Like, why care so much about soil surveys, reports, and soil information? For us, for me personally, I work in nutrient management. A lot of the times that means addressing issues that are related to soils, agriculture, and water quality. And most of my time is actually spent on issues like this. And one of the, you know, technical pieces behind it are soils, because when we talk about an aquifer being contaminated by nitrate, we're talking, you know, about a mechanism of nitrate leaching through soil. It helps to know how vulnerable your soils are to leaching versus runoff. Here would be another example of where, you know, agricultural nutrients are going into waterways, causing issues. And, you know, one of the technical pieces is that soil properties have an enormous influence on controlling how not just nutrients, but other possible contaminants or substances can move into waterways, either groundwater or surface water. So in nutrient management, soils are very critical. And that was, for us, the initial reason to get this going. Of course, you know, I'm trained in soil science. There's a whole bunch of other applications for it. And so while there was this water quality / nutrient management driver, I was thinking there's a lot of potential for a lot of other work. So the first person we thought of was Deepa, who does interact with that broader audience. But just as an example of a concrete example of how we use it in nutrient management or environmental farm planning, how I got connected with your group today was through an environmental farm plan advisor who works in the Kootenays And one of the things we do with environmental farm plan advisors is, before you go out to the farm, gather the information, do your homework on what's there, what water resources are there, and what soil resources are there. So these yellow lines you see on the map, this is the IMAP BC interface, but that's just one example of where we're encouraging our planning advisors to collect this different information about soil, about water, because those really will help plan where, when, to apply nutrients in a way that's both good for crops and in an environmentally responsible manner. So the environmental farm plan advisor might see that, okay, if these are the farm and field boundaries, and I'm concerned about nutrients going into this water course, the soil properties might mean that I'm going to need a buffer here. Maybe the soil is quite different on this patch, and I can actually apply there earlier in the season when the runoff risk on that patch would be less than that patch that's just adjacent to it. Again, it's not all about the environment. There's many reasons to be interested in soils. I think people who call me get this feeling that I'm this guy who's sitting behind a desk with a headset and ready to take questions like, I want to get my soil tested, can you help me? Or what can I grow here? And those are interesting questions. I do feel like a bit of a customer service rep when I get those questions. But I don't think of those calls or those callers as customers so much as clients. And for both of these questions, often the underlying interest is, what do I have to start with? What soil do I have to start with? And what does that mean in terms of management implications? So before they stick a shovel or a probe into the ground to get a soil sample, which is really good for soil fertility or soil chemical, soil nutrient testing, I try and back it up and just say, well, what are the soil physical properties there? And those are things that won't change much over time unless there's been some major disturbance like land leveling or fill being added. So knowing what physical properties there are with soils can really help you determine the course that you can take or the different directions you can take to answer those questions of what can I grow here, I want to get my soil tested. So more often than not, that's kind of how I feel sometimes with being bombarded with a lot of calls, but SIFT has been able to really take the burden off of answering those questions, because it allows me to interact with users in a way that's much more dynamic and interactive. So this was how I felt often before SIFT, and still sometimes when I'm just got a heavy workload. So as part of that call, and as part of the background that I think is important when you're looking at the information in SIFT, is the fact that soils can vary quite a bit. And in my world, the agriculture world, a good example would be when we go into a field that's maybe 10 hectares, maybe less, maybe 3 hectares. Within a stone's throw away, you can have 3 different types of soils. So the profiles here are the pits that were dug. If you're looking at them, you can tell that there's visual differences, and when you look closely, one implication of that is that you can grow crops with much deeper roots in one part of the field than another. And that's the type of information that you can glean from a couple of clicks in SIFT. Management-wise, another good reason to know about soils is that the initial question might be, well, what's wrong with my plants here? Or what's wrong with my blueberry crop? I'm adding a lot of fertilizer to it, and yet it still won't respond. There's something going on, and it's definitely not fertilizer or nutrients that are a limiting problem here. If the grower had recognized that this silty clay loam was particularly vulnerable to compaction, then they'd be more conscious of the compaction and that would limit root growth. And essentially that's what's going on in this photo. Those roots are hitting that hard pan, and they're not able to scavenge further down for water and nutrients, and that's the fundamental problem. And really, you know, this is something that you need as a grower to just know right off the bat before you establish, especially a long-lived crop like blueberries, so you can get yourself off to a good start. So what I wanted is not for a grower to be able to say, okay, I'm on this exact spot on a map, what is my soil here, but to be able to access the soil survey information so that they can narrow down what are the soils that are most likely to be found here. So I wanted to be able to, you know, as a user, click on a part of an interactive map, bring up information about it, like the texture, the surface texture, drainage information, kind of coarse fragments I can expect to find. And then the other neat thing is only soils, they have a name, and that's kind of a neat thing in itself, but it's a very practical thing too, because that name is linked to related information. So there's different kinds of information that are out there. Again, they're in very disparate places. SIFT is a place that, you know, just puts them a couple clicks away as opposed to a few Google searches away if you even knew to search for that. So management-wise, that Nehun soil is linked to a specific page in a soil management handbook. And that would be the case for regions like the Okanagan, the Fraser Valley, and the Southeast Vancouver Island. For the Kootenays, I think Deepa may get into how we might fill in those gaps later, but the idea stands, right? There's a particular soil with particular properties. What does it mean in terms of management implications? So I wanted to be able to get to a page like this in a couple clicks, right? I know it's a Nehun soil, or most likely it's a Nehun soil, and I want to know about, you know, soil limitations, the suited crops, management inputs that I would need to put in to be successful, and then some unsuited crops that I should probably stay away from if those are the soils that I have to work with. So that sets up, or that's the background that I think we'll set up for Deepa's demo. At this point, I just want to acknowledge the contributions from Growing Forward 2. That's a federal, provincial, territorial agreement that's really allowed us to work with Deepa's group and others like yourself to work on making this app work for you. So at this point, I'm going to hand it over to Deepa.
Hi, everybody, and welcome. Thanks for the opportunity to share this tool with you. I'm just going to turn over my screen. So the Soils Information Finder tool, or SIFT, is actually an online portal where we bring together all the soils information to try to inform land use decisions and other uses of soils data. So in addition to some of the agriculture-focused uses that David focused on, soil also offers many ecosystem services like water filtration, nutrient cycling, carbon storage. It's a substrate for plants and ecosystems. It's also home for burrowing animals. It provides shelter and protection. It's also a hotspot for biodiversity in many of our ecosystems, including wetlands, forested sites, as well as grasslands. It's a non-renewable and enduring resource. It took 10,000 years to form in the most mature areas within British Columbia. And soils information or soil pits also give us information about the history of a site. It provides clues to the paleoclimate, the change in sedimentation over the years, and big events like volcanic events, landslides, and flooding can give us an indication of frequency of those events. The soils also reflect the vegetation, climate, topography, and disturbance history of a particular site. So it can really give us lots of clues and background information about an area that we're working in. Mapping of soils across the landscape gives us an idea of rarity, distribution, and patterns of soils that can inform broader landscape planning. And it also provides background information and familiarity for a particular study area or farm site, for example. I would like to just start by showing you what's on your screen here, which is the Soils Information Finder Tool webpage. It's the landing place, and we wanted to make sure that it was Google searchable and findable with changing government websites. I always advise my users to Google search it. I don't even have a bookmark to the page in my own desktop. On the web page, the first bit is actually for launching the tool itself. Below, there's additional information, and this is why I kind of asked in the beginning, what kind of ways do you use mapping data? And so we had a lot of people that use KML and Google Earth. So you can access the data that I'm going to show you in the interactive map through Google Earth files, both the soils data and the ag capability data. As we refresh data, though, these KMLs get refreshed a little bit behind when we're refreshing the actual interactive tool. I didn't see any Power GIS users show up in the poll, but if you work with GIS people and are looking at advanced analysis, this top download, you get the full meal deal, like all the data that goes into the Soils Information Finder tool. And as well as David described, some of the first steps were the soil survey reports and the scan maps of all the legacy soils data that's been collected, mostly between the 60s and 90s. And that's what's in the Soils Information Finder tool. These two links here also give you links to further information. What I'm going to focus on is the Soils Information Finder tool mapping interface. So I'm going to click on that. And the map interface is an ArcGIS Online interface. This data is also available in IMAP for those of you familiar working in IMAP. The ArcGIS Online gives us a little bit more flexibility to build a tool to suit our user needs, as well as more surround and context we can provide in an ArcGIS Online mapping interface. So the first two tabs really are about soils. And so that's kind of the introduction that David gave, as well as some of the ecosystem services I described. And also at the bottom here, a way to get back to the web page, as well as an email for questions about the Soils Information Finder tool. So the TEI mail email link that you get when you click on this Let Us Know goes to my group. So there's 6 of us. And if people are away, we always manage information requests to this email. It's also the email that you would use for information requests for ecosystem data and superficial geology data and other related data sets. But if you have suggestions about the SIFT tool or questions or have trouble using it, please send an email to the TEI mail and we will get back to you. So the About SIFT tab goes into a little bit more detail about the data and the different pieces of information and what those pieces of information might be used for. As a first-time user of the SIFT interface, you may want to spend some time with this tab to understand what is available on the site and why you might care. So David went through some of those, and I mentioned some of them with the ecosystem services. I'm just going to show you the navigation of this sidebar. You can navigate by clicking the down arrow. You can also navigate with these little toggles on the side. And the toggles sort of correspond to the content that's across the top of the page here. So if I click on, for example, the agriculture capability information, this part of the interface tells us a little bit about agriculture capability and a link to the standards that inform this data. Oh, so I didn't wait for the map to drop, but it would have showed you where agriculture capability data is available. So really, sorry, those first two tabs are about why do we care about the soils and kind of a link back to the group that manages it. The next four tabs really are the meat of the site. This soil survey tab is probably where the most information is available about soils itself. And in future versions, we may collapse some of these tabs. So I'll explain why in a few minutes once I show you what this is. So the soil surveys are mapping projects that were mostly done between the 60s and 90s. We've digitized that information and it is GIS ready. These light gray areas in the province show where we have detailed GIS information. The rest of the province has 1 to 1 million level soils of Canada data, but where these light gray information is, this is where the more detailed soil surveys and reports about soils and all these named soils are described in detail. There's a variety of scales within these data sets. And then we also have data sets like this one up in the Skeena here, where it was a reconnaissance level project. And I'm just going to get the report coming up while I talk. It's a reconnaissance level project, and we have the report and possibly some scan maps, but it hasn't been digitized yet. So all these pink areas means there's information there, but the information is really hard copy or scanned information. Whereas the light gray areas, as you zoom in, you'll actually get soil polygons. So at this, when you first come into this tab, when you click on the polygons, it's going to give you information about at the project level. So in the area that I click, this is the biophysical soil landscape inventory of the Skeena Iskut area. And I just want you to notice here that I hit 2 records when I click there. And the way to scan through the records is this little next feature button at the top. So I can scroll through. The other one, as I explained, is that Soil Landscapes of Canada, which is the 1 to 1 million scale map. So you might say, oh, I'm interested in the Skeena area. You know, what are my choices? My choices are a 1 to 250,000 mapping project and a 1 to 1 million. If I go over to the Kootenays, whoop, I hit 4 projects where I clicked there near Kimberley. So I have the soil survey of the Upper Kootenay and Elk River Valley, which is kind of an odd scale, but it's around 1 to 60,000. And there's other information about the report, like that it was done in 1965, that might help me to decide which project I want. There's that 1 to 1 million again. And here's the 1 to 1 million, but like a newer version that was updated in the agricultural areas. I also have this project at 1 to 50,000, which is the soils of the East Kootenay area in Cranbrook. Oh, and look, that one was done in the 70s and late 80s. And so I can scroll through and kind of say, oh, you know, that's probably the one that I'm most interested in. So if we zoom in closer, the actual soil polygons, as shown in Dave's presentation, show up. And this is where I get the soil mapping level attributes. So in this area, I've clicked, you can see it's still that same report, because we've sort of sorted out for you, yeah, you had 4 reports available in that area, but you know, this 1970s and 1980s report is probably the best one. It had the best scale and was the most recent report, so that's the one that we're going to show in detail when we zoom into the area. You can still click on this and get the same report, and we'll move over. Oh, actually, I'm going to get that going. It takes a while to download. So I can click on that and look at the scan of the report, but I also have some summary information about the soils in that polygon. So as Dave explained, this polygon has the Mayuk soil, which happens to be a silty, loamy soil that is well drained and has 0% coarse fragments. Soil polygons can be complex. They can have more than one soil. So this polygon has 80% of this Mayuk soil and 10% of a soil called flagstone that we don't have a detailed description of. So with the Mayuk, I have also some other links here to find out more about that soil. So I have the summary information of what its texture and coarse fragment and drainage is, but I want to know more about that. So I'm going to click on that soil, which takes me to the report. And in the Kootenays, we don't have all the soils to the page number of that soil, which is something we're adding. But you could find the Mayuk soil in the table of contents and then go to the page in the report. I'm not going to go right there, but I'll show you the kinds of information. To find out more information, like a word description and some of the variations of that soil, description of its classification, its landscape setting, and other things about each soil. You can get more information about the soil by getting to the report. In addition, with our partners in Agriculture and Agriculture Canada, there are also these federal description pages of the soil. So that link took me to the Mayuk soil description on the federal pages, and it tells me what kind of classification happens to be an orthic Utric Brunisol. If that doesn't mean anything to you, you can keep drilling by clicking on that and read about what an orthic district Brunisol is. Tells me a little bit about that this is an agricultural profile, so that there is some agricultural disturbance. Some descriptions of the parent material and the general chemical properties. And then at the bottom, there's this generalized description of a typical soil pit for that soil name. So this isn't the actual chemical properties or a pit where I clicked on the map. It's an average of that particular soil name. So it tells me, again, what I would be expecting in this kind of soil, as David describes. So this is where it's really important to work in those interdisciplinary teams and really get to know your local soil scientists. A lot of this might mean something to some of you, but it might be gobbledygook. But soil scientists, like when I look at this, I see that there is a 10 centimeter plowed horizon that is organic rich at the top. It's calcareous rich profile, which might, cause some root restricting. There's no coarse fragments. I can look at how much sand, silt, and clay are in that soil type. And then some other information. Sorry, I have to move my video window here to see what I'm pointing at. About water holding capacity and other chemical properties of the soil, some typical properties of that soil. So the whole point is that when you click on the polygon, you get the high-level description, but you also get a way to dig down and find out more detailed information about that particular soil. I'm going to scroll down to the bottom here. We've also added a bunch of information from Climate BC to each polygon, as well as elevation and slope information. So we've added the climate normals from, currently it's the 1960 to 1990, I think it's 1961 to 1990 climate normals. But the frost-free period, the growing degree days, the slope, both average, minimum, and maximum within that polygon. So you get an idea of the variability within that area. Again, the elevation, min, max, and the average for that polygon. And then some kind of project identifiers. At the bottom, this is actually important when you contact anybody with a question, or if you're reporting on a particular polygon in a report. The project identifier takes you to the more information about the project, and this EcoPoly ID takes you to more information in our operational data set. And I'll also point out at the top, this SIFT number or ID is an enduring number that if you want to refer to a particular polygon in a report, you can refer to that number. So I want to show you some more tools available to interact with the map. You can zoom to addresses at the top here as you would in Google Earth or other things, but you can also zoom to attributes within the data set. Oh, I should have looked at what that number was. Just going to write it down, 95142. I actually don't know if this is going to work, but we'll try. So if I want to look at an attribute of the soil survey polygon, I might type in that number and we'll see what happens. Okay, this is the hazard of a live demo. Here we go. I didn't get any results. Let me do Kootenay. Oh, sorry, I should have gone slower there. So this is searching on the different report names. So when I type Kootenays, I get some, it's another way of searching the information. So you can do it as a all or geocoding, which would be an address, or you can also search the information in the project boundary. So you're searching the project level attributes. That's why the first search didn't work when I did it. So I'm going to close that. And I want to zoom back into, let's zoom into another area. I'm going to go, let's go into the Creston area. Okay. So there's also these light colored tools at the top here. This is another set of tools that you can, it opens up additional tools. And I also want to draw your attention to this little drawer in the bottom, which gives you access to the attribute table as well, the full attribute table, which you get in the pop-up box. So I just want to go through some of these tools available so you know what's there, but I invite you to explore them. So the bookmarks, I have some canned bookmarks here that zoom you to different areas in the province. You can also add your own bookmark and your browser will remember those bookmarks unless you clear your cookies and everything, in which case you'll have to recreate them. But if you work in a particular area or areas commonly, you can add bookmarks so that the tool will zoom to those areas. You can use the measure tool to get an idea of distances on your page. Oops, but it's not doing it.
Deepa, you have 5 minutes left.
Oh, thanks. Okay. You can measure and you can also put markers that give you your location on the map. You can change the base map to view. You can view the layers. In this case, there's only 2 layers, but I'll show you that in the ag capability where it makes more sense. As well, the legend in this doesn't make sense because it's not colored. It only gives you a legend if you've actually themed the polygons. You can also print your map to PDF if you want to include it in a report. And I want to quickly, in my last 5 minutes, show you the query tool. So you can also query within your window different conditions like attributes from the soil survey. So as we saw when we clicked on a polygon, there's a bunch of attributes including slope, frost-free period, growing degree days, and other attributes. You can search for within your window how much of the landscape is between 0 and 20 slope. And when I apply it, it'll take a moment to think about it. And then it shows me, oh, look, all the valley bottom is really flat. But you can also build quite complex tools and ask the data some more complicated questions. Okay, within that flat, where are the areas with growing degree days greater than 1,000 or whatever it is? I want to quickly show you the ag capability. So the soil texture and drainage are simply colored themes on that layer I was just showing you. It's really only useful if you're looking at a very broad area and you want to get a sense of the variety of textures and drainages across. Of course, I zoomed it to somewhere where there isn't any. To give you a broader idea across the landscape of the distribution of some of those attributes. So fortuitously I kind of zoomed into a similar area. And this is where that legend makes sense. So this is the different textures. And I can see that sort of the sandy and loamy oranges where those textures are in the landscape. Similarly, the drainage tab also gives you, and this is one of the reasons we want to collapse this into one tab, is that it doesn't sync up the zoom where you've zoomed into, but we can put these layers in one tab so that you can turn them on and off, which will probably be a future improvement to the tool. So this one, again, a color ramp showing where drainage is poor, you know, on the well to very rapid side, and where the polygons are poor or not. Some areas are blank because those soils aren't well defined in our databases, which is something that we're continually improving over time. I'm going to go a couple minutes over to the questions just to show you the Ag Capability tab. So this is data that was based on those original surveys and translated the soil polygons as well as climate data into agriculture capability classes. And this is often used for the Agriculture Land Commission and ALR applications for changes to the Agriculture Land Reserve. So this is based on the soils data and climate information, but it gives you what the agriculture capability for that piece of land is, using the Ag Capability classification, which on the first About SIFT, there's a link to that. If this is data that you're familiar with using, again, you'll be familiar with this coding, it'll mean something to you. So I just want to point out something about the coloring. There's two things about how these polygons are themed. Any polygon that contains class 1, 2, or 3 has a hash over it. And then the polygons are colored by the dominant agriculture capability class. So it's possible that in a polygon, the dominant class might be 5, but the third component in the polygon is high capability. It'll have a hashing mark over it. So it just highlights visually in the landscape where the hotspots for ag capability are. So that's a high-level overview of the Soils Information Finder tool. I also want to reiterate that it's really good if you get the opportunity to work with soil scientists and learn more about what these codes and soil names and how they can be useful for your particular work or interests. I'm just going to remind you that the first 2 tabs tell you why you care about soils. The next 4 tabs, when you're zoomed out, tell you about where the data is and gives you links to the reports and the high-level information about the soils reports. And as you zoom in, you get more detailed information about the soils polygons and the summarized climate information, as well as detailed information about agriculture capability of those soils polygons. With that, I'm going to open it up for questions. So I think I'm passing it back to Adrian, right?
Yes, hi Deepa.
Hi.
The first question, how comprehensive is the data in the Kootenay region?
A very good question. So in the Kootenays, most of the data is based on the, I was trying to look at the title, the biophysical resources of the Kootenay area soils. I'm going to reach it on my shelf and knock down 5 things, but it's this report right here. And so all the information on the Soils Information Finder tool are based on that mapping inventory project. So there are soil pits that were dug to inform the mapping, and we've basically just provided the information available here in an interactive way on the map. So currently, the BC government doesn't have any requirements for soil data being collected on private or on Crown land to be submitted to the province, as we do with fish and wildlife and other projects where through the permitting process, there's a requirement to submit data. New soils data, there's no policy or requirement right now for new data to come in. So all the data that I currently manage is mostly this legacy data from the soil surveys. Comprehensive, it covers most of the Kootenays. So I'm actually going to go back out here so you can see. It basically covers, you know, except for the very northern end, we have good coverage at mostly 1 to 50,000 scale. Hope that answered the question.
Great, thanks, Deepa. Another question is, you zoomed in to one of the areas in the Columbia Valley and there wasn't information there. Is that information that will be added in the future, or is it that the information, what was it? The information is going to be added digitally?
Yeah, so I think what the question is about is that, you know, it might have had the soil, but then not had the, you know, for example, this one, it doesn't have the texture, the drainage, or the coarse fragments. It's because this particular soil, the Waycliff, didn't have detailed information in our databases. Sometimes the information is in the soil report. And what we're doing over time is adding those attributes into the report. And part of this, I'm just going to see if there is one for the, yeah, so sometimes it's because the soil in the map had a particular flavor, like it was a well-drained version of that soil, and that's not in the database, but sometimes there's a generalized description of that soil. So even though that polygon I clicked on didn't know what texture it had, in the federal page, it still tells me that it's a glacial till and it's medium textured and it has a pH. So sometimes the gaps are because of connectivity in the database. Sometimes it's because we don't have a description of that soil, and that we are improving over time. In fact, I have new data being delivered at the end of this fiscal, and we are filling in a lot of the soil descriptions in the Kootenays. So I'm hoping that in the next refresh of the data, some of those gaps that I clicked on will be filled in with, you know, you'll click and there'll be a description here instead.
Excellent, that's great. That was the, oh, I think we just had another question pop up. Do you have any suggestions, recommendations for prospective soil scientists that are based in the Kootenays? It seems like most current soil work is being done in the Okanagan Kamloops areas.
Yeah, so soil scientists are kind of few and far between, like the actual specialists, and it's great to get in touch and get to know your local ones. And so Greg Gutzik and Wayne Blashen in the Kootenays are very familiar with those Kootenays soils. People like Scott Smith and Bob Maxwell, though they're Okanagan based and you know, in other areas, sometimes they've had involvement with the Kootenay inventories. So yeah, I think you're right. I think partially the activity in Kamloops is because their True University has quite an active soil science research and professors that are focused on that. So I think that's a lot of the knowledge is focused there. Greg Utzik is a really good resource in the Kootenays. And one of the other issues is a lot of the soil survey soil scientists are retired or, you know, passing away even. That's why it's so important to get out in the field with those people. I've had the privilege and been very fortunate to get out onto the ground with a lot of these soil survey specialists, and if you get the opportunity, take it. The other thing I'll point out is the Pacific Regional Soil Science Society, which I want to say the annual membership, Dave, please correct me, is in the order of $30. It's very inexpensive. They have education opportunities like this one, as well as kind of field opportunities and you get to go out in the field and meet a lot of these soils experts. It's a great society, and I would highly recommend for people to look it up. There's usually a spring workshop and a summer soil ID course that rotates around the province. You can check out the Pacific Regional Soil Science Society webpage to see where those are coming up, and if they come to the Kootenays, go to them. They're awesome.
Great, thanks, Deepa. there was a comment too, if you could make available the contact information for the people that you mentioned, we could send that out to everybody after the webinar.
Okay, I will ask them.
Okay, that's great. And one more question. How detailed has field investigation been to support the mapping?
Yeah, that's an excellent question. So there's a field, and I'm not sure if it's filled in where we are here. No, it's at the project level. There's a field called survey intensity level that describes in broad terms the percentage of polygons that were checked. It'll also be written somewhere in the report. So most of these soil surveys were probably in the between 20 and 30% field checking of the polygons. So the mapping procedure is more that you map the landscape from air photo interpretation or image interpretation, and then you go out in the field and dig a bunch of representative soil pits, and you define soil names and descriptions kind of at that landscape level. So that's where I was describing that clicking on a particular polygon isn't giving you those chemical attributes or the exact profile of that spot. That particular soil name may have had 3 or 4 pits across the study area, and then the description is sort of an average of those pits when they're describing the soil at the landscape level. So this isn't sort of a comprehensive every 200-meter soil pit kind of data set. It's a scattered soil pits, and then that information is informing what kind of character or physical attributes the soils have across the landscape. The good news is that soils are defined in a way that ties the climate and topography to a parent material, like a glacial till or a river gravel, and predicts essentially what kind of soil development would be on that particular site. So that's what the soils mapped data is based on. I hope that answers the question.
Great, thank you, Deepa. That's all the questions that we have for now. So I'd like to thank Deepa and David for presenting today. And I'd also like to thank everyone for joining us in today's webinar. We hope you enjoyed it. Please expect a follow-up email tomorrow with a link to an online post-webinar survey with just 7 questions. We appreciate your feedback as it will help us plan for future webinars. Our next webinar is Lentic and Lotic Riparian Assessment, a Standardized Approach, Monday, March 12th at 10 a.m. That would be Pacific Standard Time. And a registration link will be included in your follow-up email. So we hope to see you then. Thanks again for joining us.
Ciao.
Thank you. Bye.